Hey guys, today we are going to go over Unit 1, Lesson 12, Triangles and Circles, Part 1. Okay, your learning goals today are to define and identify points of intersection associated with triangles. Use a compass and straightedge or technology to construct points of intersection in the triangles and circumscribed and inscribed circles of triangles. Okay, mostly that's going to be done within your lesson, so please make sure you take a look at that. Okay, starting with your incenter. It's the point at which the three angle bisectors of a triangle intersect. Okay, so if I draw some angle bisectors, let's start with this one right here. It cuts this angle in half. Okay, that is an angle bisector. This one down here would also be an angle bisector, and then this one over here is also an angle bisector. Okay, the point at which all of those meet, that is called your incenter. Okay, your inscribed circle comes from that. Okay, an inscribed circle is a circle inside of a figure. Right now we're talking about a triangle, and touching exactly one point on each side of the figure. Okay, so if I get my little tool here, okay, right here, it's touching that side. Okay, it's touching one point of each side of the figure. It's touching that side, and there it's touching that side. You still have your incenter, but you have this inscribed circle. I mean, kind of inside. So inscribed is going to be inside. It says, look at the center of the circle. It's also the incenter of the triangle. Okay, so this would be the exact center of that circle. Okay, so label these missing parts. All right, so we have this line coming up right here to start with. Okay, it is drawn out of this angle. Those angles are cut in half. Okay, so that is called an angle. If it'll let me write it. Angle bisector. Okay, then when you take all of these angle bisectors and you meet them up with each other, that right there is going to be called the incenter. Okay, moving forward. Let's talk about the circumcenter. Okay, so it's again a center. Okay, it's the point at which the perpendicular bisectors of each side of a triangle meet. Okay, so now we're going to look at perpendicular bisectors. If you look right here, we have all these perpendicular lines drawn against each side. So against each side of the triangle, we draw a perpendicular bisector. Perpendicular means that it goes up and down 90 degrees. So that's a 90-degree line drawn in accordance with the line right here. Okay, when you draw all of those perpendicular bisectors, the point at which they cross, and usually they're going to be outside. Sometimes they'll meet inside, but sometimes they're going to meet outside. That right there is called the circumcenter. Okay? A circumscribed, so circumcenter and circumscribed go together, is a circle that is circumscribed about a triangle if each vertex of the triangle lies on the circle. Okay, so this is the vertex of the triangles have to lie on the circle. So not the circle touches a line inside the triangle, but this time the circle goes around and touches each point of the triangle. It says, notice the center of the circle. It is also the circumcenter of the triangle. So that point right there. Alright, let's go and label these. Okay, so we have all these perpendicular, these lines aren't drawn, but I'll draw them for you. All these perpendicular bisectors, okay? So when they all meet, like I said, sometimes they'll show up in the middle. Let's go ahead and label what I just called these. These are perpendicular bisectors. Okay, and the point at which they all meet, oh, that needs to be moved over there. Let's move that right there. Okay, perpendicular bisectors goes over there. And then the point at which they meet is called your circumcenter. I know these words are brand new. You would never use these in common language, so it's very important that you would use some kind of note, some kind of graphic organizer, and I'll try to put one together for you to keep track of all of these different items. Okay, so it says the blank is where the perpendicular bisectors meet. Okay, so perpendicular bisectors, that goes with the circumcenter. Okay, next one. The blank is where the angle bisectors meet. So we got perpendicular bisectors, go to the circumcenter. The incenter is where the angle bisectors meet. Okay, here's another example. True or false? To be circumscribed around a triangle, a circle must go through two of the vertices. That's not what we showed. This is the picture here. Alright, so that's going to be false. It has to go through all three. Alright, so in conclusion, to find the circumcenter of a triangle, you construct the perpendicular bisectors of each side and determine where they intersect. To find the incenter of a triangle, you bisect all three angles, use angle bisectors, and determine where they intersect. A circle is inscribed in a triangle if the inside of the triangle touches the point on all three sides. And a circle is circumscribed around a triangle if it is around the triangle and contains all three vertices. Again, I'm going to try to put together a graphic organizer so we can keep these all straight. Until then, I'll see you next time.